How could you tell if this relation was symmetric? If the relation is symmetric, it will be symmetric about the diagonal. So if I look at the set rock, paper, scissors, and I have the relation scissors, scissor, rock, paper, paper, rock, paper, scissors, paper, scissors. So I have rock, scissors, I have scissors, rock, and I have paper, paper. And if I think about going through the main diagonal of this, if I flip across the main diagonal, whenever this element is included, this element's also included. And the elements that are not included when you flip them. So if you were to like flip the table, transpose the table, it would still be the same table. That's how you can tell it's symmetric if you write out the table. Look for across this diagonal line, is everything the same? You can tell reflexive if you're in this finite relation situation by looking at whether or not the entire diagonal is covered. Does that make sense? Yeah. So reflexive, you can check the main diagonal. And everything in the main diagonal should be covered. There isn't really a clean way to see transitive that I know. So transitive is a lot easier when you do a graph of these things. So you can also do what's called a directed graph for relation. For the one I just drew here, what you do is you do circles for each of the elements, and then you have arrows if one is related to the other. So here I have R related to S, and S related to R, and P related to its sum. But it's not so easy to see symmetric. I guess it would be like everything can always have either a loop or you go forward and back. But you can see reflexive really easily, because if you had reflexive, it would just be having loops from the elements to themselves. So this is not reflexive because R doesn't have a loop to itself, and S doesn't have a loop. Reflexive means you're going to be seeing the diagonal elements, which would be like RR. So RR would show up in a directed graph representation as